Hey guys, so you've been learning how to find valence electrons by drawing the Bohr model of a certain element, but there's actually an easier way for you to find the valence electrons, okay? So you can either draw a Bohr model and count the electrons on the outside energy level. The test can give you a problem where you look at a Bohr model and then you just count the electrons on the outside energy level. So that's two ways to find the valence electrons. Or there's this third way, which makes things a little simpler. So the periodic table is separated by groups. I'm going to go over here to the periodic table. It's separated by groups and periods, but we're just going to talk about groups for now. Groups go up and down. So everybody in this group is group 1. Everybody in this group is group 2, and we usually actually skip these guys in the middle and don't use them. They're still there, but for valence electrons, we're not going to use them. This is group 1, 2, this is group 13, 14, 15, 16, 17, and 18. Again, groups go up and down. So group 1 is hydrogen, lithium, sodium, potassium, and so on, all the way down. Everybody in group 2 is here. So if you look at your notes, I have blocked off group 1. Everybody in group 1, if we look at it, has 1 valence electron. So that's the outside energy level, it has 1. Outside energy level has 1 valence electron. 1 valence electron and 1 valence electron. That means everybody in group 1 has 1 valence electron. Okay? Everybody in group 2, again, groups go up and down. And I'm going to copy that over, and I don't care what color that you change it to, just make sure you change that color. Everybody in group 2 is right here. Let's change that color. Let's do blue. Okay, and if I look at them, beryllium, magnesium, and calcium, there's 1, 2 valence electrons, 1, 2, and 1 and 2. That means everybody in group 2 is going to have 2 valence electrons. Okay, so everybody in group 1 has 1 valence electron, everybody in group 2 has 2 valence electrons. And then let's go back to the other periodic table. Remember, I just said that you're going to skip these guys in the middle. So you actually skip 3 through 12 with valence electrons only, and you go 13 through 18. So that's what I did on your notes. I skipped 3 through 12. So now I'm at group 13. And if we look at group 13, put a box around it, everybody in group 13 has 3 valence electrons. Boron has 1, 2, 3, and aluminum has 1, 2, 3. So everybody in group 13 has 3 valence electrons. So you're just dropping the 1 to be able to remember how many valence electrons group 13 has. Okay, then you go to group 14. Group 14, so everybody in group 14 is going to have 4 valence electrons. So if I look down here at group 14, carbon has 1, 2, 3, 4, and silicone has 1, 2, 3, 4. So you are following the group number, and that's what gives you the valence electrons, except for 13 through 18, you are going to drop the 1 with the group number, and that's how many valence electrons you will have. Because remember, you cannot have more than 8 valence electrons, because our rule for drawing the Bohr model is 2, 8, 8. So there's no possible way to have 15 valence electrons or 16 or 17. The most you can have is 8. So look at group 15. Everybody in group 15 is going to have 5 valence electrons. If you count the electrons around nitrogen's last energy level, that's 5, and phosphorus works the same way. Okay, group 16, everybody's going to have 6 valence electrons, because if you take away the 1, you're going to have 6. So oxygen has 6 valence electrons, and sulfur is going to have 6. Everybody in group 6. So I just gave you 2 as an example. Everybody in that group will actually have the same amount. Let's go over here to 17. Okay, 17 is going to have 7 valence electrons. If you count fluorine and chlorine, They both have 7 valence electrons. Okay, our last one, group 18, is a little bit different. There is 8 valence electrons in that group for everybody except for one of them, which would be helium. Okay, let's do this last one. Group 8, for the most part, is going to have 8 valence electrons. Helium is the only one that has 2 because it is full. Remember, group 18 is going to have 8 valence electrons, and if you remember about 8 valence electrons, that means that your outer energy level is full or stable, which means it's non-reactive. We want that last energy level to be full so that it doesn't react with any other element. But if I look at helium, it has 2. But if you remember our rule for drawing Bohr models, you have 2, 8, 8. So its first energy level is full, making it with group 18. So group 18 is the noble gases that has a full outside energy level. It is non-reactive. Okay, so now I've helped you learn how to take the group numbers and assign them the valence electrons, so that's easier. Now you don't have to draw out the Bohr models to check. So I'm going to go back to the periodic table just to show you. So if I look at, let's do a different one. Let's do Se. Se is in group 16. That means it has 6 valence electrons. If I look at Pb, which is lead right here, and I go up to my group number, it has 4 valence electrons because it's in group 14. If you look at the periodic table, the A's give you how many valence electrons it'll have. So if I'm in group 17, I have 7 valence electrons because I got that from the A. If I'm in group 13, I have 3 valence electrons. I got that from the A. That means everybody in this group has 3 valence electrons. So it is much easier to go to your group number and look at the valence electrons.